Alright, so last week we practiced... What? Last week we practiced trigonometry using basic triangles. However, quite often we're given more complex shapes and we have to discover where triangles can be found. Now, quite often in our problems we'll need to draw in an extra line to make a right angle triangle, but do be careful of just drawing in lines and really hoping there's a right angle triangle there. So today, quickly I'm going to describe a couple of places where you can safely find right angle triangles. One of the most common one is an isosceles triangle, this one on the left. An isosceles triangle is defined by having two sides of the same size. There. Now, if you draw a line vertically down the middle of an isosceles triangle, what you get at the bottom is two right angle triangles. And those base lines, either side of the right angles, are going to be of equal length. And this angle at the top will be equal. So that angle that you've split will be equal, as will those two base angles. It might attempt at an alpha, but basically indicates that those two are the same.
Is that one looks like a fish?
Yes, yeah. It's a fish. Now, the next shape across is titled a chord. A chord is actually this line going across a circle. Okay? Now if we draw a line or two lines from the centre out to either end of the chord, alright, so lines from the centre to the edge of the circle are both radius lines. They are both the radius of the circle, and that makes them the same size. And what you really create is another isosceles triangle. So if you take lines from the centre of a circle to either end of the chord, you know that those two lines are equal, and therefore you have, in effect, an isosceles triangle. And all the rules that apply to an isosceles triangle, so you can bisect the middle and get two right angles with two equal baselines and equal baseline angles, those ones, those apply to the chord also. Now I realise you'll have seen some of these before, which is why I'm going through them quickly. Alright, who knows what a tangent is? Tangent? It's basically a line that touches a circle. Here is our example. It only touches at one point, and one point only. But if you draw a line from the centre of a circle to where a tangent is touching, we get a cool property that creates for us a right angle here. Right. And now if we were asked to create a right angle triangle from this, we would be constructing another line there. That is bizarre. Alright, two other shapes quickly with a parallelogram. And yeah, sorry, I know this is a lot of writing, but these are things worth knowing. And to create right angles in a parallelogram, you can draw straight lines between the parallel sides. And with a kite or rhombus, if you draw lines between the points, you get right angles in the centre. Now the reason we're flying through all these different shapes and looking at where right angles can be created is because you guys would generally be given problems where there's not an immediate right angle. And you'll need to draw a line in that creates a right angle, and then you can start using trigonometry. So it's important to know where you can safely draw a line in to create a right angle. Can I go down? No, take it in. Alright. Now this is one people get wrong regularly. If you're looking at an object and you're looking up, it's called the angle of elevation. So the little blue man on top of the building, he's looking up at an angle of elevation. If he wants to be looking at a bird or something up here. If he wants to look down at the girl, that's called an angle of depression. So anything below the horizontal is depression. And if the girl is looking up, then that's elevation. So it depends on the reference point. Yeah, it's worth drawing. Or if you'd rather write your own definition for it, but as long as you know the difference between an angle of elevation and an angle of depression. And generally, when you're given the problems, they won't be given with a picture. You'll be expected to draw that picture. When I was drawing this up last night, I was thinking Romeo and Juliet, except I got the boy and girl the wrong way around. Juliet and the other back. Alright, so essentially we're just laying a lot of foundations before getting into practice problems. Do you want me to go back up? No. Alright, so solving word problems in trigonometry is difficult because generally what we've been doing so far is they give you a triangle. However, most of your questions in the test, they won't give you a triangle, they give you a paragraph. And from that you'll need to draw a picture to construct a model that you can then use trigonometry or Pythagoras on. Now, that gives us the first rule. If no diagram is given, draw one yourself. It doesn't have to be pretty, it just has to be good enough for you to work with. Mark the right angles in the diagram. If there are none, consider where you need to create right angles by adding extra lines. So, one example would be dividing an isosceles triangle. Then, put in any measurements you're given, any angles or lengths, mark any angles or sides you have to calculate. So generally we use X and Y for lengths, theta and alpha for angles, but you can label them anything you want as long as you're clear about it. Then decide whether you use Pythag, sine, cosine or tangent. So that's either Pythagoras or SOHCAHTOA. And to help you decide, you'll need to be labeling the sides. So opposite, hypotenuse, adjacent, etc. And practice what we were doing last week there. Then check your answers reasonable. So you don't want any negative sides, you don't want negative angles, and you don't want hypotenuse to be one of the shortest sides in a triangle, it should always be the longest. And when you answer, remember units. So if they ask how many meters of elevation a man has gained, then you need to be answering in meters. Some people are copying someone. If you're happy with that process, then you don't need to copy, but if you want to copy, then go for it. Yeah. If you aren't copying the process, can you please copy down the first practice question? And when you've done that, you can have a go at drawing a diagram and then following the process above to solve it.
So you have to write out the question?
Yeah, please do. Because these will be notes you work from. And if you just look through your notes and come up with a little triangle diagram, it won't make a huge amount of sense where that diagram's come from. Yep, first step is always draw a diagram. So if that's our building, we have a ladder leaning against it. needs to get bigger, doesn't it? Okay, so what measurements can we put in? Length of the ladder, good, which is 6 meters. Good. So for this, we might need to construct a base if we haven't got one already. Oh, damn thing. And the angle it creates is 60 degrees. Why does it disappear? Huh? Really frustrating me. Every time I scroll, whatever I've written disappears. Alright, just won't scroll. Alright, what two things do we need to find? Each side. We need to find the height the ladder reaches up the wall, and we need to find the distance from the base. Alright? Close enough. And where's the right angle? Here. Okay. So, now we put all the measurements in and we put all the sides we want to find in. We need to start labelling our sides. So remember, the labelling of the sides works in relation to the angle we have. The side opposite the right angle is always the hypotenuse, which is easy for us. The side opposite the angle we're given is the opposite side, and the side next to the angle, or adjacent to the angle, is the adjacent. Alright, which should we go for first, X or Y? It doesn't actually make a difference. X, good one. Alright, so if we're going for X, we have the opposite, we know the hypotenuse, and we have an angle. So if we remember SOHCAHTOA, then which one of those three do we use? Sine, good, because we have the opposite, the hypotenuse, and an angle. So if we're looking here, and we've got opposite and hypotenuse, then we're up here with sine. So we can say that sine 60 is equal to O over H, so opposite over hypotenuse, which will be X over 6. Good. So how do we move the 60 to the other side? Just do it. See, this is something that people can get confused with. The X here is being divided by 6. The opposite divide is multiply. We need to multiply both sides by 6. Which gets us 6 multiplied by sine 60 equals X. Which might even come out as a nice whole number for us. No? 5.2 what? Yeah. It does. Right. We are old school.
That's a much better line.
Much easier to understand how we X, Y. Meters. Now, really, this is 5.196. But if we round it to 2 decimal places, then we're looking at stopping here. The 9 rounds up and becomes a 2. So the 9 rounds up to 10, which rounds this to 2. That makes sense. So for 2 decimal places, it would be 5.20 meters. All right, now y. We're finding y, meaning we have the adjacent hypotenuse we know and the angle. So of Sokatoa, which ones are we using? Ka. So Sokatoa, adjacent hypotenuse. Cos 60 is equal adjacent over hypotenuse, y over 6. Same trick, we multiply both sides by 6, so 6 cos 60 equals y. Therefore y equals exactly?
Yep.
3.00 meters. Okay? So, draw the picture, label the sides, label the unknowns, put in the right angle, and work through it. And I'm afraid we have a couple more examples.
Is it the same thing?
Similar. And I will fix whatever I'm doing to the eraser. Okay, question number 2. I think we have 3 in total. Yep, this is the second to last one. A hiker is hiking 12 degrees up a 12 degree slope. If he hikes at a constant rate of 4 kilometers per hour, how much altitude does he gain in 5 hours of hiking? Back in again. I like hiking. I'm going hiking in the holidays. It'll be good. I'm hiking for 6 days. When you miss the bus.
Serious question, would we ever use this in real life?
For modelling, yes. This is like, I don't know, it's a bit like building the tools for later on in real life. And it's like, I guess, if you teach a 12-year-old how to hammer a nail in, they might not use it in real life, later on they might. It's not sure, but it still means doesn't mean we shouldn't teach them. Good story. Math is less risky. Alright, so drawing a picture of this. Yeah, so diagram is more difficult. We know that if in doubt, start off with the ground. The ground's always nice and constant. It's a horizontal. You're right. Ow, thank you. I had to draw it flat. Kirill is right. He's hiking, so the ground isn't horizontal. But if you think the earth, like the actual earth bit, yeah, it's curved, but for our purposes over this sort of area, it's flat. And then this hill he's on will look a bit like this. Yeah? So imagine walking from here towards the hills. We go flat for a bit and then start going uphill. And that's how you draw the diagram. And if you want, you can draw a little fella on it. Can we leave parking alone? Yes, I do. Alright, so what we want to find is how high does he go? The altitude will be this bit here, and we can label that X. Now the altitude is the vertical distance above the ground, so that's where our right angle comes from. Because if you imagine a hill going like this on flat ground, then the distance from the top of the hill directly down to the bottom will be a straight line meeting at a right angle at the bottom of the hill. That's where our right angle comes from. The trickier thing is how we put measurements in.
Well, isn't this slope whether it makes the ground, isn't that 12 degrees?
Good, very good. So here we have 12 degrees. Other measurement. Well done. Why? Speed equals distance times time. What that's saying is that if he hikes... No, I lied, I got that the wrong way around. That's true, but it's not very useful for us. Distance equals speed times time. That's better. If he hikes at 4 kilometers an hour, that's our speed, for 5 hours, then he'll hike, each hour he's going to hike 4 kilometers. So 4 kilometers times 5 is 20. He's going to hike 20 kilometers. Distance equals speed, which is 4, times 5 hours, 20 km. So this length here will be 20 kilometers. Yeah? Get it? Cool. You're drawing in trees. Lovely. Alright, so now we have right angle in, signs labelled. What we need to do now is figure out which theory to use, or whether we use Pythagoras or trig. So we've put numbers on the sides, but let's actually label them. So the side opposite the right angle is our hypotenuse here. And the side opposite the angle is the opposite, which is the one we want to find. So if we remember soft katoa, we have the hypotenuse and the opposite. Which one are we using? Sin, good. Sine 20. No? Thank you. Sine 12. Equals opposite over hypotenuse. Opposite is x over 20. Multiply both sides by 20, we get 20 sine 12 equals x. Therefore x equals and units are good. .16 kilometers. Is it much easier once we've drawn the diagram? Yeah. Alright. Before we go into the second one, the third one, how many of you remember this triangle? Good. Speed, distance, time. Essentially, if you want something, you cover it with your hand. So speed, if you want the speed, that equals distance over time. If you want distance, you cover distance, and that gets us our distance equals speed times time. That's important to remember. And remember that for this to work, all the units have to be in kilometres, and the time has to be in hours, which will get us speed of kilometre per hour. Okay? That's something that just needs to be known by now. And it's something that we'll use here. Last question before I let you start practicing. A balloon is hovering 300 metres above a lake. The balloon is observed by the crew of a boat as they look upwards at an angle of 20 degrees. 25 seconds later, the crew has to look at an angle of 65 degrees to see the balloon. How fast is the boat travelling? Alright, so what does the diagram of this look like? Still around the question. Right, big. Alright, so let's start off with this drawing with a sea. Let's make the sea this, or the lake, wherever the boat is sitting in. If you want, you could draw it wavy, but in reality, for architect's purposes, it's flat. And then we have our little boat. It's a very buoyant boat. Alright. Now, if we're sitting in the boat, what does an angle of 20 degrees look like? Is it like that? Like that? Here? Over this way? Oh, you guys are going out this way. Alright, I'll move my boat. You can go either way. Alright, so angle of 20 degrees is about out here, yes? It doesn't matter which side you do it. And this is our little balloon at the start. Yeah, hot air balloon, sure. What about an angle of 60 degrees, 65 degrees? Yeah, more vertical. More like that. Now, notice my height above the lake has stayed the same, because it says a balloon is hovering 300 metres above a lake. So, from there to there, the height hasn't changed. The distance between the balloon and the lake is the same throughout. Now, we don't actually have right angles anywhere yet, do we? So how do we get a right angle?
I have a question.
Sure.
About the 65 degrees, does that start from like the lake, or does it start from like the 20 degrees angle?
Starts from the lake. That's angle elevation. Alright, we have no right angles. How do we get them? Down? Yeah. So, dropping lines vertically is a good way to get right angles. From there and from here as well. It is. What measurements can we put in? 2 degrees, good. So this here is 20. And that there, 65. Other measurements. Gentlemen, do you want to have a go? Boys, other measurements. What else can go in? Good, Jack. 300 metres. This one here. And same again here. Now I know this is confusing, that's because I'm going through a huge range of questions from difficult to very difficult this lesson. Whereas in reality you'll start practicing at the easy and work your way up to this sort of question. But this is the hardest sort of question you can conceivably be asked at apps level. So if you're getting this, then you're doing well. Now we want to know how fast the balloon is travelling, so what speed, how fast the boat is travelling. So essentially the boat has moved, and it looks like the balloon has moved, but the boat will have first of all been looking at an angle of 20 degrees of the boat at the balloon, and then as it moves closer, it goes like this. Can you imagine that happening? So if you fix a point on the corner of the wall and ceiling up there, as you move closer, the angle increases. You see that? Yes, I know I'm looking like Hitler's saluting, but the angle goes down, yeah? So, if I know those two angles, if I know this low angle and this high angle here, then how can I find out how fast I'm going? Huh? No idea. Alright, to find...
You won't have one.
Good. Speed equals distance over time. Now we have time, don't we? We've been given time, it's 25 seconds. We need the distance. Except we don't have the speed. Good. So here, to find speed, we need to have distance and time. And we have time, but we don't have how far the boat's travel. And how far the boat's travel is effectively between here and here. The two changes as the angle changes, which is distance between there and there. Do you want to redraw it so the boat moves?
Sorry, that's enough.
It won't take me too long.
Can we just pretend with mine?
Sure. Okay, so now the blue is being blown by wind going from right to left. Huh? Yeah, sorry, it was a bad diagram. Alright, so, same thing, we still need the distance. And to find the distance, we can think about this as two triangles. If we find this distance here, between there, and call that x, and then we find the distance between there and call it y, the distance the balloon, now we're talking about the balloon, the distance the balloon has travelled is from the end of x to the end of y. So we get that by doing the y minus x will get us this distance here. Okay? Yep. But fortunately you can all find x and y because they're just part of triangles. Fortunately, yep. If you need to, you can take one triangle out, and it's called a working triangle, and just take it off to one side. 65, 300, x. So if we're looking for x, we need to label our sides. We have opposite and adjacent. So which one are we using? Tan, soka, toa, opposite and adjacent. We got an O and an A, so it's toa. We can say that tan 65 equals opposite over adjacent 300 over x. Yes, good. So now you can think about the tan 65 and the x swapping places. So x equals 300 over tan 65. Yep, 0.89. Now take our y triangle. Thank you. So these two little triangles I've drawn below are simply taking out the two triangles from above. And again, we have the opposite and the adjacent, meaning we will use tan. So tan 20 equals opposite over adjacent, 300 over y. Y equals 300 over tan 20. Y equals 300 our distance travelled is going to be equal to the y, take the x, Now we have distance and time, but they're in the wrong units, really, aren't they? They're in meters and seconds. You can do it like that, and it'll get you a speed in meters per second. But let's say the same argument, we wanted kilometers per hour. How would we do it? Yeah, good. So to get meters into kilometers, we divide by 1,000, which is 0.68435. How do you go from seconds to hours? Divide by 60 gets us to minutes, and divide by 60 again gets us to hours. So we do the 25 divided by 60, and then that we divide by 60 again. And gets us a very small number. Sure. Yeah, so we find the speed, the distance and the time in kilometers and hours, put that into the equation, and we get speed in kilometers per hour. The balloon is going quickly. Alright, now don't stress if that last question was hard, because it was, and it'll take a while to build up to that. What I'd like you guys to do today and tomorrow, and it was meant to be the boat, remember? Although balloons can go pretty quickly with the wind. Alright, so today, tomorrow, tonight's homework, and tomorrow night's homework, these, lots of them. So 3D is what we started last time, but this time 3D is working with those isosceles triangles, the chords and the tangents. And then 6E is working with practicing word problems. And yes, I know it's a huge number of questions, but this is our last SACE test. And this is where the bulk of the marks will come from in that SACE test. So yes, I'll leave it there, and this will be the work for the relief tomorrow and on Friday, although you can use Friday if you want to do your folio. I have no idea.